Hello everyone, how's everybody doing? I hope you're doing better than me. Yesterday I had a big glitch and all systems failed. What can I say? I hope you can hear me fine today. Can you hear me? I hope so. Yeah, just let me know if you can't hear me. I'll try to read the comments there, okay? Anyways, what happened was I updated Windows 10, um, and I didn't realize it changed a lot of my set points. That's what happened. And among them, it changed my microphone to the computer default rather than to the camera, which is what I normally use. That's why you couldn't hear me. And that was the only thing that failed. I usually check video and I usually check sound, not so much sound, before I go online. And yesterday, I just took off, checked video, said, well, the video's working fine. I didn't even check sound at all. And usually I check also the comments people make, okay? Every now and then. I can't check it constantly because otherwise I lose my train of thought. And in general, I like to keep track of what people are asking. If there's something interesting, I might comment on it. And yesterday I didn't check. All systems failed. I didn't check anything. So yeah, I got to get better at that. Like one guy said, which he hit it right on the nose. You're the flathead. Love you. Yeah, I was a flathead yesterday, terrible flathead, so I deserve that. Let's see if we can do a little better today. Anyways, talking about comments, I'll say a couple things that's important for those people who are interested. You wanna ask a question. I have no problem answering it, but I'm not. I don't answer on YouTube. I do not answer on Quora. I do not answer on Facebook, except to some of the friends there. Um, it just takes too much of my time to go through all these sites. I answer only questions at Rational Science in Patreon. Now, I don't do this to get to force you to give me a donation. Absolutely not. It has nothing to do with that. You do not have to pay a buck to ask a question. I think, as far as I know, all you need to do is register with Patreon. You can ask any question you want. You can go to Rational Science and put a question there. So if you want an answer to your question, go to Patreon, no problem. If the questions are good, I'll answer them. Otherwise, again, I'm not going to waste time with questions that are not of interest to me. Okay. And talking about questions, yeah, we had a few questions, and that's how I'm going to start the day today. Three or four guys, not my friends for sure. They don't like me very much, and they criticize some of what I said in some of the videos in the past, and so they put some questions there or some criticism. I want to address those criticisms, and so let's start with the first one. One fellow put this comment. Okay, he says he put several comments, and I was interested in all of them. First, he said I'm attacking straw men. I don't know. Unless you put an example, I have no idea what strawman you're referring to. But the most likely strawman that people throw against me, the notion that I raise strawman, has to do with the fact that they say I raise semantic issues. And they think this is, a trivial issue. Well, you're doing semantics, you're doing language, you're doing word games. How can I answer that question? The answer is science is word games. Science, the definition of science, my definition of science, rational explanations. If you're going to explain a theory, you got to get the language straight. I'm sorry. You got to get the language, you got to get precise in the language, very precise, because that's the problem. That's 99.99% of the problem. The language. People say energy, and they say, I'm going to transfer energy. What do you mean you're going to transfer energy? Energy is a concept. We can transfer a rock, we can transfer a chair, we can transfer, I don't even a house on, on one of those trucks. you cannot transfer a concept. You cannot transfer love. No one can suffer for you, in pain in your own skin. No one can love for you. No one can think for you. Because these are concepts that you have. These are dynamic concepts that we, in ordinary speech, we turn into sometimes, poetically, as a figure of speech, we turn them into physical objects. So we reify them, we make them concrete. You can't do that in physics. You can't take energy and define it as a concept, the capacity to whatever, and then say, I'm going to transfer the capacity. No, it's not literal. See, physics is literal. So you cannot change that concept into an object and think that you're transferring, I don't know, a spirit, some kind of foam or gas or whatever you have in your mind. So language is important, and that's usually what people refer to when they say that I'm attacking strawmen or raising strawmen. Okay, now he continues. He says, like, who cares who his audience is? I guess he was referring to Nassim Haramein and some of the other guys that, I analyzed the other day, or the marketing spin, or if it includes spirituality. What should that matter? Well, yeah, I think it does matter. It matters. Certainly, we don't want to introduce spirits into physics. We're dealing with physics here. I mean, if you're going to do spirituality, you're in the wrong site. You should go to your Sunday school, raise that up with your priest. But if so, it does matter if someone raises spiritual issues, which is what quantum mechanics and relativity do. They work with concepts. They don't work with physical objects. And physics starts at the physical object. You absolutely need an object to do physics. Okay, and his audience, well, I was just making a comment that these people are out to get votes. They're out to get hits. They're out to get money through the people who visit their sites. Okay, and the problem there that I see with all these dissidents, people who object to the establishment, is that they're taking people who are intelligent, who laymen, who go out there and say there's something wrong with space-time, something wrong with this Big Bang and black holes and dark matter. Invisible dark matter is so heavy we can't see it. Something is wrong there. So the guys have this intuition that something is wrong. Where do they go? They go to the dissidents who also object against that. They object against space-time and a lot of the stuff from general relativity and quantum mechanics. But what do these people have to offer? Well, they have to offer, you have the electric universe, they offer plasma and electricity. You have the John Chapel Society, as I call it, they do particles, they do ether and this kind of stuff. You go to Ken Wheeler, theory, hypothesis, and what does he do? Well, he does concepts. He moves concepts around. He moves dielectricity and what is it? Inertial and radial, whatever, because all these spirits that he moves around. So, the question is, what's the alternative? Are you going to go with these people? And yeah, so these they do is they take people who object to the establishment and not people who really have something to offer in exchange for what the establishment proposes. Why not spend more time discussing the theories? Well, I think I spent a pretty good time analyzing the theories. I went over the theories of the de Hilsters who proposed particles. I went over the theories proposed by theory hypothesis, Ken Wheeler. I went in past over theories of the electric universe. I went over that several times now. I do go over the theories, and I think I pinpoint what is wrong with them, what I see not wrong, what's irrational about them. And then I compare them against what I'm proposing in exchange. So I think I do go quite a bit over the theories. But if I miss something, if there's something that's not clear, hey, go to the Rational Science Patreon, ask the question. Okay, why not try to find the overlaps, the parts where you can agree? And that's the one that really ticked me off about this guy. Who do you propose I go with? Should I go with The Flatearthers, I'm going to talk about that today. Should I go maybe with Ken Wheeler, who moves concepts around? Should I go with the electric universe? They move a concept called plasma. They plan to do electricity across the universe with plasma, where you need at least, I would say, as a minimum, 10 to the minus 3 torr across the universe to send electricity from planet to planet, star to star, galaxy to galaxy. And there is no such monster out there in heaven. All we have out there is like 10 to the minus 11. Space is pretty much empty. You have a little bit of solar wind here and there that fills in some of that vacuum, and that's what confuses people into thinking that the vacuum is full of stuff because they detect something. Yeah, you do, but hopefully, the astronauts out there don't get zapped by electricity constantly, from the sun going to Alpha Centauri or whatever. So no, who am I supposed to join? Am I supposed to join these people? Is that what you're suggesting? I mean, if these people are all flat earthers, because that's what they all are, they're all flat earthers, I'm not going to join them. I'm going to criticize them. Believe me, there's nothing in which I agree with them. Nothing at all. Now, you might say, well, we agree on what we oppose. In that sense, yeah, there is a common ground. I'm not saying that we agree completely on that. I have a different focus on what the establishment does, and a lot of that has to do with the language they use. And these people have not figured that out. So they use the same words as the establishment. They're still doing physics with particles, and they're still doing physics with waves. If you can find anything outside of waves and particles, please let me know. Okay? So for me, as far as I'm concerned, they're all in the same boat. The dissidents as well as the establishment. Okay? I've got a different proposal. It's the rope model, and I'm saying all atoms are interconnected, physically interconnected. If you can find that anywhere in the literature, if you can find that in any blog, informal blog, oh, let me know. I'd like to see it. And I'm going to find that it's not there. What they're going to talk about is waves and particles, and they're going to talk about energy, and they're going to talk about fields and a lot of garbage that has nothing to do with physics. So no, I'm not going to agree. I'm not going to join other groups that have the same problems as the establishment. Okay, let's move on here. Here we have another comment by another gentleman. He says, I'm not sure scientists exist by your definition. It's interesting because my son said the same thing. And the answer is yes, you're totally right. Science started in the 21st century. Okay, I hope that's very straightforward. Science started in the 21st century. Before that, we never did science. Why? Because for the first time we have the foundations of physics. Before that, we never had any foundations of physics. We had no definition of what physics is. We had no definition of what science is. So all these people that have been working for the last 10,000 years, they were not scientists because they didn't know what science was. And you say, well, Bill, that's pretty arrogant of you. That's pretty self-aggrandizing, right? And so let's do the following. Let's take Bill Gates out of the equation. Let's take the word science out of the equation. Let's take the word physics out of the equation. So that doesn't hurt our feelings and we don't get involved in semantics. Here's the $1 million question for you, okay? Here's a phenomenon. Two little magnets, okay? They stick together. Here's the $1 million question. Are you interested in understanding how Mother Nature does this magic trick? That's the only question. Let's not talk about physics. Let's not call it X. Let's not use name calling. Let's not do anything else. Let's just figure out, are you interested in knowing how this magic trick is done? And that's what we do here. There's a lot of verbiage out there, a lot of things one says, informally, etc. The issue is, are we interested in knowing how gravity works? Are we interested in knowing how magnetism works? The mechanism. That's the issue. That's the primary, that's what we should focus on. Okay? And so, whether this guy's a scientist, a physicist, whether he's a mathematical physicist, a dissident, an amateur, a professional, those are labels. I know engineers I work with that weren't worth a damn. And they had degrees. So, all that is very relative. But when you go to something specific, you say, do you want to understand how magnetism works? Yes or no? And that's the issue. Let's figure out how a magnet works. And right now you can't find that answer anywhere on the internet. Not how it physically works, how it attracts, the mechanism of how a magnet attracts another, or the mechanism of how a pen falls to the floor. How does gravity work? How does Mother Nature do this invisible magic trick that she does daily? Okay, that's what we want to understand. I call that physics. You want to call it X, science, whatever, call it whatever you want. That's what we want to know or understand. Okay. He says, I throw most of what you talk about in this video to the side like swimming through an ocean of bullshit belief system. Okay, I do not argue what is called God, soul, etc., ether, life, energy. Yeah, that's because you're not a scientist. That's why. Because what's happening is you're missing the important part, which is language. You think it's all semantics, and you don't want to do English. What you want to do is go to the lab and start working. Well, I did a lot of experiments when I was in semiconductor business. And before you can do an experiment, you got to do a design of experiment. You got to design it. You have to know what you're trying to accomplish. Okay? And a design of experiment requires, you're going to request funds usually for it. You're going to have to convince the boss to sign in. Okay? He's got to sign in and give you money for it. He's got to authorize funds. And so you can't just BS your way through that. You have to design your experiment. Now imagine if I went to my boss and said, look, I'm trying to find out why there are particles on my wafers from my aluminum deposition operation. I think it's all about energy. I think it's all these virtual particles that are falling on my wafers. And I don't know where they're coming from. I think they're coming from the vacuum of space. Well, what they would tell me had to do with my design of experiment. They would tell me to shove it up my nose hole, right? Yeah, language is important. And we have to know what energy is. We have to know what a field is, if we're going to use the word field in our theory. We have to know what these words mean. And I'm sorry it offends you that we're wasting so much time attacking strawmen or dealing with language when you really want to get down to physics. Well, unless you get the language straight, you're not going to understand the physics, because that's the issue today. Today we're dealing with abstractions such as energy, field, waves, plasma, electricity. That's what these people are moving. Ken Wheeler, he's an exception. He moves dielectricity. He moves inertial flow of whatever. He moves counter space flows and all these things. He never defines them. All concepts. So yeah, language is important. And I'm sorry that all this wording troubles you so much. You want to get your hands dirty in the lab. Well, before you do so, you got to design your experiment, and you better word it right, and you better know what each word means, so that if someone questions you, you can answer the question. Okay. Yeah. Good old Mike Hudner there. Hi, Mike. Okay. The comment that I like the most, a couple guys, okay, they came up there with this. They said, what is preventing the Earth's atmosphere from dispersing into the vacuum of space? Thought experiment. On the ground, we have a gas pressure system chamber on bottom, vacuum chamber on top. Open the seal between the two. Why doesn't gravity prevent the gas from dispersing into the vacuum chamber? Another fella had questions along the same line. He said, explain how a vacuum can exist beside a pressurized system without a barrier. And this is not the first time I get these questions, but I thought at some point I have to address this. Some people want to know, okay? Some people want to know, what kind of answers do we give to this type of question? Okay, so I tried to simulate what these folks are trying to say. Here it is. Okay, we have a chamber. We have a chamber on the bottom. We're going to open that little hole, and we're going to let particles flow upwards into the blue chamber. Okay, the blue half of the chamber, you could say. and until they equalize and they have the same pressure. So we start out there. We have only vacuum. We have vacuum on top. We have particles on the bottom. We open the little hole, and now the particles start seeping in. Okay, that's the scenario that these people are painting. So now we get particles in the upper chamber, and eventually they even out, and we have the same, essentially the same number of particles in both chambers. Okay, so that's the situation. So the question is, how do we answer this? Why do those particles go up? Because they're going against the pull of gravity, as they said. And this is true, by the way. What they said is what actually happens. Okay, I know, because we deal with pumps that pump things to create a vacuum. We wouldn't need pumps if the particles didn't flow into a region of empty space, right? They would tend to flow in there unless you have the pump constantly pulling it in, or you have different types of pumps. You have the cryo pump. It has all these nooks and crannies where the particles attach to because of the cold. Okay, so there are different mechanisms. Okay, how do we answer this? Well, let's go first with a little balloon picture here. Why does a balloon float in the air? Well, you have four scenarios there from one site, and these are the questions that they have. They say which one is correct here. Okay, the gas molecules repel each other and get as far from each other as possible. That's scenario one. The gas molecules are more dense than air and strongly attract to each other. Number three, the gas molecules are less dense than air and strongly attracted to each other. And the gas molecules are constantly moving and are neither strongly attracted to nor repelled by each other. So they fill the entire available space. Well, letter C is the right answer. What happens is the particles tend to, um, they're moving around, and what they're doing is actually pressing against the balloon. But the reason the balloon floats, it has a lower density than air. That's essentially what it does. And I'm not going to go into in deep with this. I just want to show you another aspect of this because I want to get to another issue here. And that's if you have a volume and you make it bigger for the same number of particles. I just made it bigger so you can think of the particles as the same size, but there's the same number of particles in both of these chambers. If the chamber is bigger, then you have lower density. Okay, that's what's happening. And so the pressure against the sides of the box will be lower on the right-hand side because you simply have a bigger volume. So it's just a mathematical issue in the sense that you have fewer particles or the same number of particles for a greater volume. That's essentially it. But here's the issue I want to get to, really, because that's the issue that this second fellow put in there, and that's the one that concerns a lot of people. Let's go with this scenario first. Here we have it. We have the Earth, and again, you got to think of all these particles as the same size. It's just more difficult. I just didn't take the trouble to do it. But as you go outwards from the Earth, you have an atmosphere, and that atmosphere gets thinner and thinner, meaning that there are fewer and fewer particles of air, oxygen and whatever other stuff that's in the oxygen. You get fewer of molecules as you go outwards. At some point, you have practically no oxygen. I'm sure that somewhere between the Earth and the Moon, like midway and probably closer to the Moon, there's probably no oxygen molecules in that area at all. Okay. And then the $1 million question is, why is that so? I mean, if it's like this guy says, if there's no physical barrier, why don't these particles just flow out into outer space? Why don't we deplete our atmosphere and get it just float into outer space? Why doesn't this cloud that surrounds our planet just leave? Well, the answer is gravity, obviously, except for the Flat Earth Society. They don't believe in gravity, and so or they have a different version of gravity. So the issue there is that they don't deal with these issues. These are the issues you have to answer. And yes, since the air is all around our planet, the question is, why doesn't it deplete? Why does it get thinner and thinner and thinner and just fade into space? Well, the answer is that all these atoms, all these molecules are attached, physically attached to the center of the Earth under the rope model. There's a rope connecting all these atoms. That's what it is. Otherwise, I'm not sure that the official version of relativity and quantum, they could explain this. I mean, if you have all these discrete little balls, beads, which is what they claim the entire universe is, just discrete balls, nothing to do with each other, they're not connected, why don't they just drift out? What keeps them bound to the earth? And they'll say, well, gravity. Well, yeah, but what is gravity? I mean, what is gravity in physical terms? And that's where they lose because they have no. They can talk to you about gravity and mass, and they can put the equation, say this is how it behaves, but they can't tell you the physical mechanism. With a rope model, yeah, they're all connected. So an atom is connected to the center of the earth. All atoms in the universe are connected to the center of the earth. And the only difference between them is distance. That's it. It's very simple. Okay? But let's continue with that train of thought. Here we have which one was this? Here's the universe. This is the question people have in their minds. Here we have the universe. We have all these particles in the universe. You can think of them as atoms. You can think of them as stars. You can think of them as galaxies, whatever you want to think of them as. Why don't all these galaxies just keep spreading out and filling that black stuff there around it? Why don't they just move outwards in that direction as the arrows show there? And the issue is, first issue you have to understand, there is no such thing as space. So the black stuff is artificial that I put there. The black stuff it does not exist. There's no such thing as the black stuff. The black stuff is nothing. Nothing means that which doesn't have shape. And people have trouble getting that concept through their heads or understanding the definition. So let me say it one more time. The black stuff means that it doesn't have shape. Okay? That's what nothing means. Something is the white stuff. Something is that which has shape. Each one of those little things has shape, and the entire shebang has shape. Okay? But the entire shebang has shape only because it has a contrast. If you were God and you had all this total knowledge, this complete vision, of everything, well, you might see something like this from afar, maybe, if you're standing somewhere out there, this is maybe what you would see. So what's the black stuff? Where does the black stuff end? And the answer is the black stuff doesn't end. And the only reason the white stuff doesn't move outwards into the black stuff, as shown by the arrows, is gravity. Okay? And gravity is what? Interconnection. Because if things were not interconnected, there would be no reason for all this matter just to drift apart, right? Why does a star not just leave the galaxy? Why doesn't it drift out of the galaxy? What's preventing it? Mass? Gravity? What is mass? What is gravity? These are mathematical concepts. What's the physical reason? What's physically preventing the star from leaving the universe? The answer is they're all interconnected. They're physically interconnected. Every atom in the universe is connected to all others. Otherwise, if you don't put something in there, some elongated object that interconnects, that binds matter, you're essentially doing physics with spirits. That's what it comes down to. You're telling me that you're going to sprinkle a little bit of black magic, some witchcraft in between there, and that's how you're going to keep things attached to each other without things drifting apart. Yeah. So they have to be physically attached. Okay, since I run a little bit out of time today, I'm going to skip a piece that I was going to be doing. I'm just going to get into the flat world that some people have in their minds. And again, should I join the flat earthers? I don't think so. Here's the logo for a very popular group. Lately, the popular is becoming more and more popular. And that's their logo, the Flat Earth Society. And I hope you can see that fine. You have a little disc and you have the planet essentially drawn on it. Apparently, they do believe that, the South America and Africa and all these have the shape that the establishment proposes. I mean, they could have changed that as well. They could have said, well, no, South America is a circle and Africa's a square. They didn't say that. They drew them like the official, uh, the people who do geography and all that stuff, do the land surveying and so on. Uh, they drew it like these guys proposed. I mean, they could have said that's a conspiracy, right? That maybe South America doesn't look like that, and neither does Africa. Something to keep in mind. The question here is the sun flat there, or is it supposed to be a sphere? And how about the stars? Are they supposed to be flat also, or are they a sphere? These are important questions, right? Because I mean, if you're going to talk about the flat Earth Society, we might have to talk about the flat sun, the flat moon, flat stars, the flat galaxy. Everything is flat, right? I mean, I would think so. Maybe they're all like pancakes out there floating. I don't know. And, someone asked a question. I should have put that question there because I thought it was an interesting question. He said something like, do you really believe a globe, a ball can float out there in space? Well, can a pancake float in space? Or like I had in the picture here, are they on top of turtles like Mr. Stephen Hawking says? I mean, what are we talking about here? How do you picture the Earth? If it's a flat pancake, is it sitting on turtles? What is it floating in space? I mean, you got to answer these questions. And again, one of the issues you got to keep in mind also with flat earthers, same as all these other people, it's not about criticizing, science is not, physics is not, about criticizing the establishment. No, science is the other part, is what you propose in exchange. Science, physics is not opposing, it's proposing. You have to propose to be a scientist. Not a guy who criticizes is great, but he's not a scientist. He's a critic. Scientist proposes. He has to propose a theory. He has to give you an explanation. He can't leave the room of the conference room until he explains. He can't just criticize and leave. No way. That's not accepted. That's a critic. That's not a scientist. Okay, so I don't know. I took the liberty, okay, to illustrate their world. I hope I don't offend them. I hope that I don't misrepresent them. They always accuse me of raising strawmen, okay? Is this what our universe looks like? We have a flat sun, essentially, to the side there. We have a flat moon, and we have a flat earth. Is this what these people propose? I mean, what are we talking about? Is this our universe? And if so, then again, we have this flat disk, okay, floating in space, I guess. Or should we put some turtles underneath it? They have to explain this. You can't just say, well, it's flat. Okay, it's flat. And, where do we go from there? Okay. But see, these are not the only guys who have flat minds, flat way of thinking. We have the people that belong to the Flat Universe Society. They're bigger. These guys are flat earthers. Here we have the flat universers. Okay, so let's look at them first. And these are people who claim to be, in the establishment. This is the Flat Universe Society. It's a branch of general relativity. And they do harp a lot on flatland. They try to explain everything through analogy. And here you can see, that they have all these visions. The one that you see on the bottom right is the Big Bang expanding through time. Time are the cross sections there. And you end up with a universe of today, which is essentially a cross section of time. Like if we took a snapshot of the universe, well, we should get a flat universe too, because that's what they say it is. They say we have a flat universe as indicated by the upper one in the center. You can see there where the one that's got a little triangle in it. That's what they think the universe is. And there you see an illustration of the flat universe. And by the way, I didn't create that. Here it is. This comes out of an official magazine. I hope you can see this, okay? And that's the one in the center. And this is a astronomy magazine of 1999, and it has to do with Mr. Stephen Hawking, how it all began. Let's see if you, let's see, there it is. Stephen Hawking and Neil Turok explained the universe's origin. And that's the picture they drew. They drew a picture of the flat universe. So yeah, these are flat universes. Universers, I'll call them. How's that? And then you have, the four-dimensional cube there, the Rubik's cube. And that's supposed to be an unimaginable universe that you can't, because it's got four dimensions. But as you can see, it's kind of squarish, and that's how a lot of people illustrate it. So you have all these flat universes out there, and that's the official version. So the flat earthers are not that crazy when you compare them against the flat universers. Okay. So what is the problem? What is the problem with flat universe? What is the problem with flat earthers? Let's get to the point, okay? Here, let's first go with the why the establishment believes the universe is flat. That's important because we got to compare them, the flat earthers against the flat universers, right? I think that's a fair comparison, right? And this is how they say, this is what they mean when they say flat. Measures indicate that the universe is flat, suggesting that it is also infinite in size. That's from NASA, okay? According to the best measurements astronomers have ever been able to make, the curvature of the universe falls within a range of error bars that indicates it is flat. Future observations by some super Planck telescope could show a slight curvature, but for now, the best measurements out there say flat. That comes out of physics.org. These are official sites, okay? So it's not like I'm putting words in their mouth. These words come out of the official literature. The universe is flat. And you would think that if the universe is flat, well, the flat earthers are not that wrong when they say, well, if the universe is flat, of course the earth has to be flat. I mean, right? I mean, I don't know. I think they got a point there, okay? That's one point for them, okay? So I don't take that away from them. So let's find out first what flat means for the purposes of relativity, of cosmic official version, okay? This is general relativity, and this is their definition. Okay, and so this is one of the sites that says, before we can get started talking about the flatness of the universe, we need to talk about flatness in general. What does it mean to say that something is flat? Yeah, good question. What does it mean? If you're in a square room and walk around the corners, you'll return to your starting point having made 4 90-degree turns. You can say that your room is flat. In other words, they're saying that if you make 4 90-degree turns, that's going to define flatness for the official version of, general relativity or mathematical physics in general. But if you make the same journey on the surface of the Earth, which is round, they're assuming it's spherical, right? Start at the equator, make a 90-degree turn, walk up to the North Pole, okay? Make another 90-degree turn, return to the equator, okay? Another 90-degree turn, and return to your starting point. You did only 3 trajectories. Now you know the universe, the Earth is not flat. Okay, so that is the definition of non-flatness. 3 turns, 3 90-degree turns. Okay, in one situation you made 4 turns to return your starting point. In another situation, it only took you 3. That's because the topology of the surface you were walking on decided what happens when you take a 90-degree turn. Another analogy, of course, is the idea of parallel lines. If you fire off 2 parallel lines at the North Pole, they move away from each other, following the topology of the Earth, and then come back together. And again, they're referring to the parallels and the meridians. Okay, they're talking about these lines that we put on the maps. Okay, but so what does parallel mean before we continue there? Parallel lines are lines in a plane which do not meet, right at the bottom there, right, in red. That is, 2 lines in a plane that do not intersect or touch each other at any point are said to be parallel. 2 lines in 3-dimensional space which do not meet must be in a common plane to be considered parallel. Okay, so these guys are not talking about parallel lines, but they're talking about lines that are not on a flat plane. That's the first problem. The second one is their definition of parallel, which they say lines that do not meet. And, that's the definition that's been held for many centuries now. And, not in physics, maybe in mathematics, not in physics. In physics, it's equidistant lines. That's what it is. We don't stretch lines to infinity to find out if at infinity they meet. I mean, am I supposed to walk along the parallel lines all the way to the edge of the universe to find out if they meet over there, maybe, perhaps? No. We take two lines, we say, are they equidistant right here and there? And if they are, then we have parallel lines. But see, they don't like that definition because they like to do definitions through motions, through proof, through experiment. And that's not how definitions work. Those are operational, functional definitions, which are non-scientific. And so the definition currently that we have today in mathematics is an irrational definition. It's not valid. Okay, but let's continue. So what does this guy say there at the end? He says, well, what about the universe itself? Imagine flying out into space on a rocket for billions of light years, performing 90-degree maneuvers and returning to your starting point. You can't do it in 3 or 5. You need 4, which means that the topology of the universe is flat. Okay, so how do they define flatness? They define it operationally. They say walk, do an experiment, walk around your room. If you made 4 90-degree turns and you return to your starting point, your floor is flat, I guess. Yeah, it's an irrational definition. And so the issue is you have here the Flat Earth Society. They have the word flat in their logo, in their title. What does flat mean? How flat is flat? Okay, so let's look up the word. Let's see what flat means, because that's where these people should start, or should have started, because I didn't find a definition for the word flat in their site. Okay, so, and they skip that step usually because they don't think it's important. It's like, oh, you know what flat means? Well, I don't know. Let's find out. Here's the definition of flat, the official definition of flat. Okay. And this is from the dictionary.com, okay? It says adjective, yeah? Hopefully flat is an adjective. And it says horizontally level. Is that what flat means? That it's horizontally level? So I take a cube, perfect, ideal cube, God's cube, and I go along the surface, and I don't find any dent. It's perfectly smooth, ideally smooth. Is that what we call flat? The cube? Is the cube flat? And of course people would say, well, no, the surface is what's flat. So it's important to keep in mind what we're talking about when we're saying flat. Are we referring to the surface being flat, or are we referring to the cube being flat? Let's make that distinction. Keep that in mind, okay? Let's continue. Level, even, etc., the same thing, essentially. Having a surface that is without marked projection. Same thing. Essentially, they're looking at surface. They're saying if it's smooth, right? No dents, no accidents or anything in it, okay? Lying horizontally at full length, okay? Lying wholly or against something, okay? That's thrown down, laid low or level with the ground, okay? Again, the surface issue. Having generally level shape or appearance, not deep or thick, okay? Okay, well, they got a couple more spread out and unrolled map, okay, whatever. The point here is that they're looking at surface, and they're saying if the surface is even, right? It's not, it's completely smooth, perfectly smooth, ideally smooth. Then we have a flat surface. But that doesn't mean that your house is flat. Okay, so we're talking about two different things. Are we talking about your floor being flat, Or are we talking about the tiles being flat? Each one of these tiles. And if we're talking about the tiles, the question is how flat is flat? Because obviously there is a thickness there, right? So these definitions do not include provision for thickness. That's the point I'm trying to make. Okay, so let's give you my definition of flat, and that's the one I proposed for physics, okay? And here it is. Okay, it says lacking thickness. That's what flat means. And only ideal planes, such as squares, circles, can be said to be flat. There are no flat objects in the real world because everything is three-dimensional. Anything which is three-dimensional is not, by that definition, is not flat. Okay? So now the question is, under that definition, of course, people are capable, or they have the ability to propose counter definitions. I'd like to hear them. What do they mean by flat? How flat is flat? How flat is the Earth? I mean, I think we can say that Mount Everest sticks out from the ground, so the surface of the Earth is not flat. So that would violate the standard definition. It certainly violates my definition because it's 3D, and clearly, if it's 3D, it can't be flat. So what do these people mean by flat? That's the question. And yeah, anyone who has a definition is welcome to put it out there. If they have a perfectly, and again, it's got to be a definition that's scientific, not some religious nonsense. But let me continue. Translucent, someone said. Yeah, that requires a vision. That see, it's translucent to you, but not translucent to me. That means that it depends on your opinion. And again, we don't use opinions in science. The first thing we do in science is kill the witness. No observers allowed. It has to be an objective definition. So anything involving measurement, anything involving opinion, anything involving, taking the measuring tape and saying, well, is this flat? Let me run an experiment. No, that's not a scientific definition. That's an operational or functional definition, which means it's a definition after the fact. That's what it is. You're going to say, well, let me prove what flat is. You're going to prove what flat is, the definition of flatness. Yeah, let me prove it to you. Look, I measure, and if I don't see any bumps or anything, then I'll call it flat. So we don't know if it's flat in advance. And that doesn't work in science. In science, you got to do it in reverse. You got to define what flat is. Then you can do all the measurements you want. You can go out there and kill yourself if you want. But you got to define the word objectively. And that's what I'm saying. Lacking thickness. You don't need to measure anything. All you have to do is say, if it lacks thickness, by definition, it's flat. And the only thing that lacks thickness is, like in the case of the cube, the surface. Only, a sheet. A zero-dimensional sheet. In other words, it has no thickness. That can be said to be flat. Only. For the purposes of physics. It's an ideal concept. There is no real physical object that is flat in the universe. Okay? So the Flat Earth Society might have to change its name to the Pancake Society, and say, well, it's not really flat. It's more like a pancake, if that's what they mean. Okay? But then the question is, how flat is flat? That's one issue. The other one is that, you got to tell me if it's the Earth is sitting on turtles, okay, or what? How it's floating out there? How you do gravity? And gravity is I'm not going to go over that today, but it's kind of fancy how they do gravity. The Earth coming against the apple, Newton thought the apple was coming towards his head. No, he was going towards the apple. With the ground pushing him up, yeah. It's quite fancy. Okay, what is the real problem with a Flat Earth Society? That I see, the main problem. It's a religion. It's a religion. Why? Because they're in the business of conspiracies. And conspiracies, there are conspiracies and there are conspiracies. There are political conspiracies, killing of Kennedy, 9/11. There's a lot of conspiracies out there. And not everybody believes in the same conspiracies. And a lot of time, all these people are bunched in the same boat. Oh, you believe in 9/11 was done by the government. You believe Kennedy was killed by the government. You probably believe that the Martians landed in Roswell, and you probably believe in the Flat Earth Society, and you probably believe that man didn't go to the moon. So they tend to bunch everyone in the same boat. And it's part of the strategy. You treat everyone as a flat earther. Okay, so that is part of the argument that people raise. So you don't want to be caught in that. No, no, there are conspiracies and there are conspiracies. Some are valid because that's what intelligence agents do. Agencies do. They work on false flags. They have to do false flags. They have to do something and make you believe something else. That is their job. That is what they're there for. In fact, I think it's the what is it? The motto of the Mossad, the intelligence agents, the agency of Israel, that says we conquer by deception, and that pretty much synthesizes what all these um, organizations do. They have to conquer by deception. The United States spends $85 billion a year on intelligence. Now, why would they spend all that money if if they're not there to deceive? Okay, that's their job. That's what they're there for. But this doesn't mean that everything is a conspiracy. And yeah, you have to choose your conspiracies one by one. Okay, and the flat earthers have this idea that the government is trying to deceive you by saying, look, they're trying to make you believe the earth is round, spherical, instead of flat like a pancake, because they need to, there are several arguments. One of the arguments is that, they need to have money coming into NASA. And you would not approve funds going into NASA if, the earth maybe were not round and all that stuff that they're telling you about sending rockets to the moon and to Mars, if all that is BS. Okay, so that's one argument that I heard around there. And there are a couple of others, but they're all in a conspiracy mode. And again, we have to go back to the definition of science and of physics. What is physics about? What is science about? It's not about criticizing. It's not about saying, oh, they're doing this because they don't want you to know. That's a criticism. You still have to propose something in exchange that says, this is how the universe works. And you can't just do it with the Earth. You can't just say, this is how the Earth works. Now, you got to tell me how a galaxy works, how a star works, aside from, the Earth itself and every phenomenon we have here on Earth. You got to tell me what is, not what ain't. And I think this is where the big problem is. Most of the time when I listen to a couple of videos, conferences that these flat earthers have, and a lot of it is just criticism. A lot of them is, oh, it's a conspiracy. It's they're doing it for this reason. They're trying to fool you. Well, fine. That's the sales pitch. Tell me what is. Tell me what science. Tell me something about science. Give me an explanation. And that's where they fail. And yeah, they're going to have trouble explaining gravity because gravity is done in a spherical manner. Um, my proposal is that every atom in the universe is interconnected. That means that all atoms on the earth are interconnected and pulling towards the center of the earth. In other words, they're connected to the center of mass of the earth. The only way you can do that is, with a spherical model. And that applies to every celestial object. That's why everything is round, because of gravity out there. With a flat Earth, well, I don't know. I don't know how you're going to explain gravity. I certainly can't explain it with a rope model, because that means, maybe I could explain how the atom at the edge of the pancake is pulled towards the center because they're tied together. Okay, I can explain that, but I cannot explain the one that's perpendicular to flatland. That's the problem I'm going to have. What about this atom over here? How is that one falling to Earth? How is that apple falling to Earth? I would have trouble explaining, at least with my rope model. So, it's not for me to put words in their mouth. It's up to them to put these explanations, these mechanisms in front of you so that you can judge. And again, most of this is just bashing the establishment because people are just overhyped about conspiracies. Conspiracies are fine, but you got to choose them carefully. You got to know which ones are conspiracies, which ones aren't, and everybody's got a different opinion about those and a different take on them. For sure, I'm not going to join the flat earthers to bash the establishment. I'm not going to join the Electric Universe to bash the establishment. I'm not going to join I'm part of the Chapel Society only, like I explained in a couple videos ago, simply because I signed up, but not because I am with them intellectually. So I'm not going to join any of these groups or Ken Wheeler or Eric Dollard to bash the establishment, because I think what they propose in exchange is much worse and means that they're not in their sound minds, you know, how this universe works. They're in no position to tell the establishment, that they're wrong. They're all so-called wrong. They're all irrational. They're all proposing irrational theories. Okay, with that, I might continue with a little bit of flat Earth, explaining a couple things about them next time around. And again, once more, I'm sorry for being a flathead yesterday and not noticing the sound. Hopefully, I won't commit that error again, or I'll be cut loose. We'll see you on Sunday. Bye bye.